If I'm not getting more feedback, perhaps I'll begin. My name is Peter Wood. I'm the Director of Architecture from Enriquez Partners Architects. I was the Associate in charge of Woodward's project, and I'm the Director in charge of the Telus Garden project. I would like to thank everybody for having me. I'd like to tell the story of Telus Garden. It's currently under construction, and we're really excited about it because there's a lot of really interesting and new things, ideas we're exploring. Before I begin, I would like to play you a marketing video which captures the essence of the project. Hopefully you can hear this.
A planned space, a garden, new life sprung from tired soil, a new home in our own backyard. Stone, wood, and glass trained into form. Its beauty will entice, its design will inspire. This will be sustainable. This will be nature in balance. It's air, water, and light aligned by innovation. A place for opportunity, a place for community. We will work here. We will live here. We will set root and grow here. This garden is a place to cultivate the most important things in life, because this garden is our garden.
I hope it's not supposed to be done by 2012. So if you're having an uncontrollable urge to lease the office space or buy condominiums, this is a very effective video. I love this video only because it seems to be an architect's dream. The gentleman at the drafting table was my boss, Gregory Enriquez. He actually doesn't sketch much, but in this video, he sits down at a beautiful glass drafting table, sits down in one sitting, drafts the idea. It magically appears on the page. It magically gets built. Materials are tumbling down Georgia Street, and it's magically built. No blood, sweat, or tears, or arguments, lack of sleep, contract documents, none of that. It's a perfect world. And then the funny thing, in the end, it's populated by incredibly good-looking people along the side. It's strange and interesting and obscene at the same time. To tell the story of Telus Garden, I could boil it down into 9 chapters. The first chapter is Metro Core Jobs Head Office. The other is context and zoning, mixed-use program, former development, sustainability, central plant, landscaping, retail animation, public art, urban theater, and public building tectonics. Just like Woodward's, there was a partnership between Enriquez Partners Architects and West Bank Developments. Enriquez Partners Architects did Woodward's, we did BC Cancer buildings, we did Eugenia, the one with the tree on the top. West Bank, Shangri-La, Fairmont Pacific, all sorts of developments. Building upon the success of Woodward's, we agreed to go in and team up in an open competition or a closed competition that Telus had to develop a piece of property they had on Robson and Richard Street, which, if you remember, was essentially a parkade for Telus. Telus wanted to see what possibilities they could do with that site. The story is about that when Ian Gillespie, president of West Bank, and Gregory went to do their presentation for the CEO of Telus. They were riding up the elevator, and they had prepared a presentation, much like today, and Ian turned to Gregory and said, "I think we've got this all wrong. Everything we've been working on for the last little while on that singular site is wrong." He said, I'm going to pitch something different, just go with it, and hopefully it works. And so what he pitched was a vision not just for one little piece of property. He actually pitched an idea about developing the entire site. So developing a piece of property owned by the City of Vancouver on Georgia Street, which was the parkade, and actually also working on redeveloping the existing Telus building. This played perfectly into what was going on in the City of Vancouver at the time. City, with all the residential development, was essentially becoming a resort town. If the scenario played on and we continued to develop residential condominiums downtown, the scenario could possibly be that we all live downtown and go to the suburbs to work. And so the city kind of recognized this, and they started to draft policies to encourage office building. Now, there's been a lot of office building in the last little while. Essentially, before that, I think the last office tower was built like 12 or 15 years before that. So there was a wonderful opportunity. On top of that, Telus kind of shared in the same vision that Ian had. Obviously, we're building right now. But their vision, when they recognized the importance of this site, it's an incredibly important site in the city of Vancouver on Georgia Street. They recognized the fact that having the two parkades and the existing Telus building, it was really a hole in the fabric of Vancouver. And they were so excited about this, they actually decided that they would not continue their plans to move their corporate offices to Telus. They had just built a new tower in Toronto. They decided to actually keep that in Vancouver because of this development, which is great because we've lost so many corporate headquarters. We lost to Calgary, we lost to Montreal, we lost to Toronto. And this, as a kind of a high-tech company with an incredible track record, it was a wonderful thing for Vancouver. Having said that, it was the perfect storm in the city of Vancouver. In respect that we were going to utilize an underdeveloped site, we were going to get corporate offices, and we were going to get more offices. So the city was incredibly receptive to any of the proposals we came. And as we'll discover in this presentation, a lot of things we did, which we submitted, we didn't expect we'd get away with, and we did. And it's just because the city was so receptive to this development. Context and zoning. Everybody knows the site. It's on Georgia Street. It's very difficult to actually drive down Georgia, and that's my fault. I apologize. With all the construction traffic. It's bounded by Seymour to the west, Richards to the east, and Robson Street to the south. It's surrounded by commercial to the northwest, the Hudson Bay, Scotia Tower. To the east, there's residential development. Forgot what the Capitol. We've got the Kingston Hotel in the middle of all this. Apparently beer sales have gone up during construction. And then we have the Hermitage opposite of that, and then of course the library. The Telus site itself, and I said that Ian saw this as a bigger vision for this site. That was the site they initially wanted to develop, just that. The bigger vision was to develop the entire site. Kingston Hotel is there. This is the location of the residential tower, the office tower, and the existing Telus building. This is where that little sunken garden was for where, I guess, White Spot was. A lot of people are very upset White Spot's gone, and I shouldn't actually break it to you here, but they're not coming back to Telus Garden. Apparently Global is not quite the same. The zoning, I'm not going to get into much detail about the zoning, but we were able to rezone this property from C1 for the office and a C3 for the residentials to a C1. We did that primarily to get some additional density. Like good architects for our clients, we got a density for the office tower of 12.24, and for the residential tower, 17.59, which is quite a bit of land lift. So I think we did a very good job with that respect to density. The interesting story, though, is not so much in the density, because I think density fits well. I think the issue and kind of the story of Telus is more about actually the height. You can see here where the office tower is capped at 300 feet. And the building height for the residential is about 450. Under the discretion of the Director of Planning, you could build, I think it's up to 450 or 500 feet in the downtown core, at least on these sites. But we were capped off by what the city calls view cones. I don't know how many of you know what view cones are, but in 1989, City Council enacted 27 view cones, primarily from Falls Creek, looking north over the city to preserve some of the views of the North Shore. These corridors, these views, and there's 27 of them, primarily are cut all through the building, all through the city, and it controls development. With respect to the office building, view cone 9.1, one that I particularly hate, of the 27. The view cone, you can see it here. There's an abstraction that we're trying to maintain a view from Canby Street. This is just about almost opposite City Hall. That this view at that particular spot is those mountains are maintained. They're dynamic, right? Because as you drive 60K, you've lost that view. But at that particular view, that's important. What it did was, it cut short a tower that could have possibly been 40 stories. And it was a little frustrating in respect that, we have this corporate commitment to down there, and we could have had a building that was twice the size, and we're cut halfway down because of the view cones. You can see here the view cone 9.1. It cuts right through the center of our site, and this is it here. This is a portion of it. This is a photo montage. The pink that you see here is our building. You can see how our building, this is a photo montage of our building. You can't see it at all. We were able to actually encroach into the view cone. There is some leniency from the City of Vancouver. For Woodwards, for the W building, we were able to get 7-foot encroachment, which was huge then. Here we got a 7'6" encroachment, so we gained 6 inches. This is huge. By the end of my career, if I can get to 7'11", I'm going to retire a happy man. The other view cone, another one I don't like, is 9.21. You can see what it captures the mountain view here. You can see it here cutting through our site. This is 9.2, and this is 9.21 this way. The interesting thing here, and the reason why we were able to build the residential tower so much higher than the office tower was the Scotia Tower. Thank God for the Scotia Tower. Scotia Tower was designed and are built and completed in 1977. It predates the view cones that were enacted by council in 1989. We argued successfully that in no time soon, they'll probably not tear down the Scotia Tower. So we argued that, well, why don't we build in front of it? Seems logical. And the city's accepted that. You can see it here. We're building a portion of our building, you can see here, steps into the view cone, so we've cut the building off because of that, and sculpted the top of the building because of it. We were able to get a view cone encroachment of about 3 feet on this, not as successful as the other one. Mixed use program. So this big, larger vision of developing this site allowed us to actually do a number of uses on the site and really kind of rebuild this part of the city. This is an abstraction of the residential tower on, the office tower on West Georgia. The yellow is commercial. The purple is the existing Telus building. The interesting thing about the existing Telus building was, at one point, that was completely full up of ladies plugging telephone. Now, 300-400 people plugging things is replaced by a little computer in a closet. Now, they've expanded that network, and it's quite huge. And there's an incredible amount of electronics now. So they've actually displaced a lot of their people who actually are in there. And at one point, we were actually working on a data center to go on top. There is really only office space in 555 Robson Street on the corner of Robson and Seymour. You can see here the residential tower in the back. That's another view from Richards, the residential podium with commercial. You can see the little Kingston Hotel there. At one time they were offered to buy it, but they didn't want to sell it. Residential, you can see a 555 Robson there, data center. There's a lane outlet here. We actually closed the lane off and bought the lane from the city, and offered this, not encroachment, easement through. So we actually closed the lane off, and this is the office tower there. Form of development. Unlike the video, which had the architect sit down in one sitting, sketch the entire idea, it's a little bit more complicated than that. And these diagrams basically illustrate all the different forces affecting the design of a building. I'll go through them. Starting with the office tower and the evolution of form here, we start with the site. This was the city parkade. It was separated by a lane. This was that little sunken garden, that commercial, as where the white spot was. So we started with that. We took the amount of essentially square footage that the developer wanted in order to make this a successful development. And you can see there we fitted onto the site, and once again that pesky view cone cut us off. And so we couldn't make, this was not financially viable. So we had to kind of figure, well, what do we do here with this extra density? And it seemed logical that perhaps we take that density and we transfer it to the other side. But we're left with a shorter tower, and in some respects we've got this orphaned piece of density there that frankly a little kind of building there on Vancouver's most ceremonial street wasn't actually the right solution. So we said, well, what can we do now? Well, why don't we bridge across, pull this thing up and through, bridge over the lane. We can connect the existing Telus building with the old Telus building, so bridge the two. And because the density was greater, we actually proposed that we would cantilever, because we were running out of room. So we just proposed, well, why don't we just go over the property line and say, and we argued by saying that, listen, these view cones that you want us to respect, cut the building. This is corporate head office. It should have more presence in the city of Vancouver. So we proposed that this presence would actually be seen on the street rather than up in the skyline. And the city actually accepted that rationale. Once again, I said they were very receptive to this development. So we were able to cantilever over the street by 25 feet. And that actually happens on Seymour and on Richards. So you will be able to drive your car underneath this building. Now, this is nothing new. When you think about Erickson's courthouses, there are developments not only in Vancouver that have done this. It's not new, but frankly, for the city to accept this now was revolutionary for us. We still can't believe it. We're still pinching ourselves that they would allow us to do this. It's pretty radical for the city of Vancouver. Every time we go back and talk to the planners right now, we come into their offices and everybody's like, every new development that's being submitted is asking to cantilever over the property line. Every development, they just hate us up there. So by pulling this bridge up, we're actually allowed to actually have a plaza there that we can use for more ceremonial spaces because of Georgia Street. The other thing is that we had this notion of actually having these public, semi-public spaces of actually occupying all the roofs, which is a crazy, crazy, crazy notion for an office tower, that people can actually go out and utilize roof space. We actually, even though in emergencies you can actually drive through the lane, there's some bollards that are removable, we needed a gesture to link this orphan site with the other. And we came up with this idea that it would be a pavilion with an arch, and the arch would be at the highest point where the lane is so they can get an emergency vehicle through. That on the plaza side, that actually becomes a covered area. It does rain in Vancouver, so we thought that was a good idea. And then it transfers into the lobby of the Telus building and almost a seamless integration of inside and outside. Inside and outside. And then we came up with this notion, we're still working on this, of actually integrating the entire block. One of the more interesting things is this lane. I always say that this is the prettiest lane in Vancouver. Kind of a weird thing to say, but it has no power poles. It has no power poles because all the copper in the province comes into the existing Telus building here, and it comes down the lane. I don't know if anybody drove by the site and they saw that big bridge holding up something. That was all the copper in the province coming in to the site, and And they constructed it, they put it onto once again, a steel bridge, and they held it in the air because it was once running down the lane. And literally, that was all the copper going into the mainframe in Telus. That was all military, that was all police, CSIS, all running through there. There were guys on call 24/7 that if there was, the bridge kind of deflected a little bit, the lines would go down. There were crews that would descend upon that. Thank God, made a lot of risk assessors at Telus, a lot of sleepless nights. Nothing happened. We held it up in the air, we built underneath it, and then we put it back again. So thank God that was safe. And then we had the simple mass. We started to sculpt it a little bit by pushing and pulling, creating these things, what we call sky gardens, which really kind of animate the facade. And then we start to articulate the skins. And you'll see this a little bit later, what I mean by that. That's it there, kind of a simplified kind of schematic rendering. The sky balconies, the photovoltaics at the top, the skin I was talking about, the bar, the pass-through here, the pavilion, the lobby. This is a water feature, a sunken garden here, a water feature there. Kind of really interesting. Same thing with the evolution of residential form. It started, like all good projects, start with a site. This is on Richards and Robson. We essentially started with a pretty typical topology in Vancouver, which is a podium, tower on a podium, and we essentially moved it away from Robson Street. And we moved it away from Robson Street because Robson Street is our pedestrian street, and we didn't want a huge 47-story tower hovering over. So we moved it back. And we moved it back to an arbitrary line, which was the edge of the Hermitage. And we wanted to maintain their views, the private views of the people living there. And then the view cone, 9.21. Cut it. You can see actually the view shadow for the Scotia Tower, and then we had to cut a portion of the building. So that kind of sculpted the top of the building. Then it's quite a big tower, so we actually broke it into 3 parts. We had a west bar and east bar, and we kind of shifted those, and we had this interstitial space. And then we started to think about this thing that it was quite a big floor plate. I think it was pushing around 9,000. So we wanted to present a thin face towards the residential development to the south and kind of a wider face to the commercial development to the north. And we did that primarily because commercial or residential towers anywhere from 6,000 to 8,000 square foot, the floor plate, versus a commercial tower, office tower, which is like 20,000. So we kind of made it fat and thin towards the other buildings and fat towards the other office uses. And from there, we felt that on Richard Street here, we had to do something with that face of that building. We didn't really care about the lane too much, but we cared about this. So we broke it into 3 different boxes to scale it down a bit because it is 47 stories tall. And then, stupidly, taking cues from the office building, was at this point we liked to cantilever 25 feet. It was in our vocabulary. So we actually cantilevered the mid box 25 feet. For those of you in the industry, taking units that come down, plumbing, structure, going boop in the middle, not a good thing, not a smart thing, but we actually made it work, believe it or not. Well, we'll see that. Eternally optimistic. There you go. Setbacks. The city also had notions of setting back Richard Street and Robson Street in order to allow a little bit of more room for the pedestrian. We set it all back for that. We set some back for the Kingston Hotel to respect. We did some ventilation there. And then we started to sculpt the bottom to demarcate wayfinding into the office lobby and the residential lobby. And then we started to texture the facades with some solar shading and some decks and so forth to break it down to a more human scale. Once again, it's 47 stories. You can see it there, the cantilever decks, interstitial spaces, the west bar, the podium, and so forth. Some of this has actually changed. We have modified some of the design. I actually do have slides of more recent design work on this, because believe it or not, we are continuously designing things. We have a relationship with Westbank that when we design something, if it costs too much, we go back to the drawing boards. Wonderful concept, but when you're under construction, we're always trying to keep up with it and keep on top of permitting and building permits and so forth. Sometimes we build things twice, or design things twice. And it's been quite be challenging, let's say. Sustainability and central plant. Telus always says the future is friendly, and I think they really probably had to believe in that because we rezoned this to CD1, we were required in rezonings in Vancouver, if you rezone it, you have to do LEED Gold. Telus said, no, that's not good enough. We want to do LEED Platinum. So the office tower is LEED Platinum, which is a commitment of not only West Bank, but Telus to sustainability in the environment. At the heart of our sustainability strategy is the central plant. As I said, the existing Telus building, which is essentially all full of equipment. It's all telecommunications equipment. That telecommunication equipment is pumping heat out, just pumping heat out. And so in order to cool it, you have to cool this equipment, or we drop all our calls, essentially. So the cooling, always cooling. And when you cool in mechanical terms, you reject heat. It seems so simple, but you cool by rejecting heat. That rejected heat currently dissipates into the environment. They just dissipate and reject it into the environment. So at the basis of what we were doing in this new development, and it's really good as part of Ian's vision, is there's this whole vision for this block rather than an isolated thing. We really look at this as a block of buildings that are connected rather than individual buildings. We actually use this low-grade energy to heat both the office tower and residential tower. Even the rejected heat here we can use in the residential tower. So we're always exchanging energy between the buildings. This term low-grade energy is interesting in respect that it's energy that, or if you could call it temperature, its temperature's not too hot, not too cold. That actually, you need a particular type of heating and cooling technology to actually build upon that. We are actually using a product out of Belgium called a Climate Canal by Yaga, which is essentially it's like for lack of a better term, like a hot water baseboard. The interesting thing about that, and we're using it to heat and cool the residential tower and to heat and cool the perimeter of the office tower. And the interesting thing about that is we've taken this like really low-grade energy, and there's little micro fans in this unit that basically draw air through, and it's able to amplify that low temperature or that temperature, and it's able to amplify it. So we're actually able to take this low-grade energy that was just wasted, amplify it with new technologies, and it essentially heats and cools the building systems. The other thing that we're doing here, which is quite interesting, is we're building upon the very nature of office buildings. Office buildings, most people don't know, office buildings in the center of them, even if you're in Calgary and it's negative 30 degrees zone, because of people, because of computers, because of lights, they're always cooling. They're always cooling the center. The perimeter where the windows are, the sun comes up, it heats it up, or it's cold outside. It's always it's more dynamic, but the center of the building is more static. So we actually used this low-grade energy and used in-slab piping to heat and cool. So we're actually heating and cooling nicely cooling, using an in-slab radiant floor. Now it's a little bit different from what you'd use in your house. We're actually cooling not from the floor up, but from the ceiling down. And this gives us an opportunity as well. And then there's all these synergies that are intertwined here, because we are using water as the medium to heat and cool. A half-inch pipe of water can move the same amount of energy as a 1-foot diameter pipe of air. So air is not a great medium to move energy around. Water is far more effective energy.
So you're on the slab, you're not on a raised floor system?
We are, I'm getting there. So that gives us, because we're not actually using air to heat and cool, all those ducts that were up in the ceiling are all gone. So now we actually have this opportunity to cool or heat down. And when they do studies, the engineers did studies, it's actually more effective to heat down than it is up. And that gave us an opportunity to actually put everything in raised floors. So we have a raised floor system, and because we're not running ducts through there, that raised floor is very shallow. I think it's 12 or 14 inches. It would be twice that if we were using air to heat and cool. So we were using this rainforest. So the only thing we're actually doing is using it as plenum for ventilation air. And so heat exchangers on the roof exchange the air going out with the air coming in, and we're using ventilation air. And the one thing about raised floors is that you can use the displacement air, and you can move little diffusers all around the place and change any configuration you want. So we're actually using that technology wonderfully. So the ceiling is, it's not a drop T-bar ceiling. It's not a dropped drywall ceiling. It's actually a concrete ceiling, which has its own kind of challenges that goes along with it. The interesting thing here is that we were able to look at the office building, and typical office buildings like 13 feet floor to floor. And because we weren't using air to heat and cool, we thought, well, why don't we kind of compress everything? And so we were able to get it down to 12'6" floor to floor. And by doing that, we got an extra floor because we didn't have enough height, right? Because we were contained by that view cone. So we actually used this to our benefit, this technology that would be a healthier, more comfortable office environment to our advantage. And in fact, we got a free floor out of it, which makes developers very happy. The other thing it did was, because we're not utilizing forced air in different zones and trying to balance everything, we're just pumping ventilation air. We're able to use windows, old-fashioned windows. If you're hot in your office or cold, you open up the window. Because we weren't having to do anything with balancing or anything, we have operable windows. So we're kind of going back old school. So we're using infloor radiant heating that the Romans used. We're using operable windows that traditionally were used. So some of these things are very advanced, but very simple. We're actually kind of going forward and going back at the same time. Going through the other sustainability features, photovoltaics. We have this huge photovoltaic that sits on the top of the building. And for us, the photovoltaic was symbolic for us of sustainability. We really felt that you had to see it. And when everybody looks at photovoltaics, you may look at triple glazing, you don't go, that's a high performance glazing. But you look at photovoltaics, everybody knows what it is, right? We have photovoltaics at the building. It actually floats across the top and actually cantilevers slightly over the building, so it's quite visible from the street. And it's really kind of our commitment to sustainability. Really cool thing about this is, once again, I was talking about those synergies. So we use the photovoltaics to capture energy for electricity. We actually also use that to capture water. So every bit of water that falls on that photovoltaic drains off, collects in a gutter, drains down, and comes into a cistern. So we collect all that in a cistern, as do we collect the water from various roofs throughout the building. We collect it in the cistern, and we use that for gray water, we use that for irrigation, and we're actually use that for a redundant fire system, because we have all this exposed steel and so forth. So there's an incredible synergy, so that we have this redundant fire system that we're actually, and our code consultant was really excited about this, and maybe a couple people in this room, I won't ask them to admit they're excited by that, but actually kind of using these redundant synergies is really quite exciting. Stormwater management, as I said, the triple glazing, you can actually see elements for passive solar shading. On the south facade, we have 5-foot cantilevered sunshades. On the east and west facade, we have, I think, 16-inch glass fins that are cantilevered off the building. The combined cooling that we get is about 5 to 7% a year. Doesn't sound like a lot, but if you're an office tower and you're cooling all the time, it adds to, it certainly adds up. Operable windows, we have fritted glass. If you drive by, you see some fritted glass, that helps a little bit. Talk about sky gardens. And the trip facilities that we have, electric cartridge, exhaust heat recovery, I talked about with ventilation. Very similar in our residential tower. We have every roof that we can. They're occupied. Stormwater management, rainwater harvesting. We have similar fins on the residential. Those are actually even bigger. They're actually about almost 2.5 feet out, cantilevered out from the glazing. And this is the first time we've actually worked with offshore companies, curtain wall companies. And traditionally, we in Canada or the United States, we go with a Connie or something, we open up a book and we size it. We're actually working with offshore companies and literally doing custom dies for every window, which for me, reviewing shop drawings is that, every gasket, we'd have to think about every gasket and stuff. But this gave us this incredible opportunity to add these elements to the facade that helped save energy. Landscape. It is called Telus garden. And as I alluded to before, that we have trees and gardens all over. This is just a quick view of the office tower. We use a lot of indigenous plants, a lot of indigenous materials as well as part of landscaping. This is the executive floor. I really want to go there. It has, apparently there's a huge wine cellar and so forth. I really want to be, if I was doing it all over again, I'd be in a Telus executive. Beautiful, they're using all the space. There's a whole bunch of Japanese gardens up there. There's bars and so forth. This is for the Telus employees. Equally, that's nice. There's outdoor kitchens, there's walkways, there's fire pits for them with biofuels. And then the sky gardens themselves will actually have some vegetation as well.